Hi and welcome back to another Legal Tech video. In this video today, I will explain to you how chip works, how smart card works, how asymmetric key works, and how you get all that connected in a clever way to increase your cybersecurity and make the life of your users even more easy than it is today. So welcome. Let me take you first to what we're going to talk about here in the physical world. So here in front of me, I have, in this case here, two tokens. These are combined USB, as you see, USB tokens. This one from Phyton, another one from Yubico. They are all FIDO2 compliance, and even the key from Yubico can also support X509 certificate. Then I also have two standard-sized smart cards, as you know, from ID cards. One here from Thales that consists of a FIDO applet as well as a PKI applet. I will get into what applet is. And this card can work with NFC and it can work with a contact chip. And the last card here, the one that says demo person, demo company, is a NXP-based card that consists of both a FIDO token, a PKI token, and as well a MyFair token for the usage with door system, etc. Then here I also have a Air ID Mini. Yeah, it looks like a car key from the company CertGate. This key here can run with Bluetooth, it can run with USB, and it can run also via NFC, and it supports both FIDO2 as well as PKI-based certificates. And lastly, an iPhone that I guess you all know already in advance, and the phone here will become also a very important item in the years to come in terms of better cybersecurity, and the phone can also act in some cases holding certificate and using the technology that is inside the phone operating system. So welcome on board and welcome to the Legal Tech video. The video here today, I will explain these things that you see on the screen. Point 1, passwordless versus two-factor authentication. What are the differences here? Chip, what is it and what can it do? Number 3, asymmetric keys, why it is this smart in a modern cybersecurity world and why that actually matters. Point 4 here, certificate authority, the trust anchor of keys. What does it do and why is that also relevant to think about? Number 5, smart card with multiple layers of options. So how is a card actually constructed? And finally, to clone or not to clone, it's actually a quite important question. So let's get on to it here. Passwordless. It's a big subject. I think for those of you that are familiar also with zero trust and these technologies, you would know that this is a big item that is being discussed and it's supported and endorsed by many companies from Microsoft and to many others that we should go into a passwordless world. I think this illustration here, this small graph, is very easy to understand in terms of saying password plus a two-factor authentication method so username, password, plus something extra. It's secure, yes, but it's not necessarily that convenient. I think we all know that. We're used to that. Google Authenticator, other authenticator apps, push apps, etc. How about going passwordless? In the sense that you do not even have a username. So you can go in and log in with your token. The token will be read by the system you connect to, and you will just be prompted for something you know, typically either a PIN code or something you are, a fingerprint, and therefore you can be authenticated. That's a true passwordless authentication, and it's very convenient, and of course it's very secure. Lastly, well, the old person in the room, the one that has been here around for many years, the password, you know, everyone knows that there's a challenge around password. They are easy to get access to sniff and to phish and all these things that goes on in cybersecurity world. So they are low security, but honestly, it's still, of course, for many people convenient. Moving forward to what is the chip? I think many people, as I just showed you a few examples here of chips. The chip can be used for quite a lot in terms of different use cases and different methods and technology. So digital sign, I think I would go from the PKI certificate. That's the keys. This is where I generate a key. I will get to in a second how this security works with the key pair. But the key pair and potentially also the certificate that is connected to this makes a huge difference when we talk about good cybersecurity. Obviously, the chip can be connected to antennas. This is what you do with the NFC, and in old days that would be also called the RFID. And there's some misconception on the technology. There are some differences. You can read about that on searching that for Google. Of course, inside my chip, I can store a copy of my photo. You know that from your passport. That's actually what is happening for those of you that has a passport with chip inside. There will be a digital high-resolution version of the image that is printed in your passport that would also be in your chip. So the chip can also hold data, which also goes on other information like name, token, dates, and other relevant information. Of course, also I can use my chip for facial recognition if that's what I want to do. That technology is supporting that. I can do the same with iris. I can do it with fingerprint. Then we come back to my digital signing. And for digital signing, this is exactly what I do when I authenticate to a system. The standards of chip are these two ISO standards. The first one here is for physical contact. The second one is for the NFC communication. And this is built on this communication megahertz, this 13.56 megahertz communication. The operating system of a chip is a crucial thing, and there are multiple chips out there. I have, in this case here, focused on the Jacob operating system from NXP. The Jacob operating system is actually an open platform, and NXP is supporting that in their chip design. So, when you look at the applet here, what literally inside the chip itself, you would notice what is very important here is this secure storage. If you have an iPhone, you would know that name as secure enclave. And for others, they can have different wordings for more or less the same function. The point of the secure storage is that this is where, when I use my key management tool, I use my ciphers, I can generate a key pair, and my private key will stay in the chip. There are no way that I can get that data out of my chip. It would stay inside that chip, and I can only communicate with my private key via some given APIs that the chip operating system and the hardware of the chip will support. And as I said, this is built on the Java card operating system. Taking a more deep dive into the chip operating system, you will see that a given chip do support a lot of functionality. I will not go through all the items here, but just say, as an example, you see RSA. This is the key side, different algorithms. What does it support? What are the reading speed of a given chip? In this case, 200 milliseconds for a MasterCard transaction. I think it's quite fast. What kind of MyFair implementation would it support, etc., etc. So there are many, many options, and this is, of course, an area that is constantly being developed. Moving forward, also just highlight to you this name called applets. And the applets is the program that is deployed in the card, in the chip, and in the card operating system. This works more or less like, from your apps that you install in a phone. And they can be signed in various ways. And what is important with the applets is that they, as an example, the passport has some given functionality or a payment card. And in this case, cards that are used for authentication to PC and to IT equipment, phones, PCs, websites, etc. And what you see here, what I just have highlighted here, is the applet for PKI and digital signature based on the European eIDAS standard. So this chip operating system and this card do support the protocols and the functionality that is required by these standards. And I think this is quite important in terms of having a very secure tool. Looking at the keys itself, typically today we build all this based on RSA key. And I will just give you an example of how that key is actually generated, because it's actually just simple mathematics. It's based on that you generate a very large random number. And with that random number, you apply that with a key generation application, and this will generate a public key, the green one, and the red, which is the private key. The private key are the one that is kept in my card or in my chip. It will never leave that. It is not possible to get that out. It will only stay there. So I will have a model now where I have something I have, my card and my key, and something I can share with other people, my public key. And the way to access my private key is by something I know or something I am, depending on the technology. Know something, a PIN code, or something I am, typically a physical fingerprint in that case. The advantage of doing that with this mathematic model is that it is guaranteed that I always will generate a unique ID. When I generate this large random number, I will always get a random number. There are enough numbers in the universe in the terms of the sizes of these keys that I'm generating, so I'm not concerned that I will run out of numbers. There are plenty, and there are a lot of research and science around key generation. So it's a big area, and for those of you that like to delve into that, I can recommend these as minimum, just these two URL that is mentioned here in the bottom of the slide. It's also important to tell you that this is a global standard. It's used among multiple industries and multiple use cases. And finally, it's built, as I said, on simple mathematics. It's quite straightforward, and authentication is either 1 or it's 0. Yeah, that's how it is. Quantum computing is the last thing I just want to mention here. This is something that we're going to see in the future. There will be people talking about RSA keys, we'll be talking about other algorithms. What I can say for now is that this will be supported, of course, by the industry. It will be supported and it's being worked on heavily by universities and research people and scientists around the world to address the development of quantum computing in terms of how to work with these keys. Looking at a digital signature, so how does the mathematics actually apply? I think this is where it really becomes clever in terms of modern authentication and modern passwordless processes. I will explain this from a simple message point of view, and you could apply the same story to authentication, where the message that Alice sends to Bob could easily be just a challenge that the operating system has submitted to Alice and ask her to sign and send it back. So what does Alice actually do? Alice has a message saying, "Hello, Bob. Alice, do sign that with her private key." This is important. So she's using her private key and her PIN code, etc., and her smart card to sign this message. So the message is submitted to Bob, and it has attached a sign payload where it proves that this is my signing sequence. When Bob then receives this message, he can then verify that the message were done with the private key of Alice by running the same mathematic with the public key. And when that adds up correctly, it will tell Bob that this message is authentic. It comes from Alice because it's been signed with Alice's private key. He cannot see the key, but he can, by using mathematics, he can simply determine that this is what happened, and therefore he knows that this is Alice. And that's exactly how an authentication also works. Reversing the process when we go into encryption is that when Bob then want to send a secret message to Alice, then he will use Alice's public key. He will create a ciphertext, and Alice will receive the message, and she will then decrypt the information by using her private key. And by that, it's not necessary to have any shared keys or like a password, have a shared secret. And this is the way that asymmetric encryption and asymmetric signing is working. Yet again, a few links here to Wikipedia. I can recommend going into the details there. The last thing around certificate is and PKI is for the PKI public key infrastructure. This is about applying a label to the key pair, knowing that this key pair has a given rights, can do certain things, or is connected to a given person. You know that from SSL certificate. By that, you can go and click on the link and the small padlock, and you can see there, what is this website connected to, etc. You know that perfectly well from SSL. This can also be applied for people and for email signing and for digital signing of documents and many other use cases. So how does that work? It works in a way that I generate my key pair in my smart card. I then submit my public key together with a certificate signing request to the certificate authority. The certificate authority can be internal in your own organization, or it can be a national or even international certificate authority. They will receive your request. They will validate that the data that you submitted are correct. It's connected to you as a person, or given on what are the given certificate that you're requesting, that the rules apply, etc., etc. They will run that process. Finally, they will generate your certificate, and they will sign that with their own private key. And that's exactly the numbers of certificate typically you see in the certificate chain. When you look in a Windows server or wherever you go, you can look at the chain of trust in a certificate. And that's typically what you see from a root CA to an intermediate CA and to the user, depending on how your design is constructed. Coming to the physical card, as you just saw here in the beginning of the video, the cards can be constructed in multiple ways. The way a typically smart card today is built and especially for the ones that has dual interface, they will be built, with the outer layers of plastic just to protect what is the kind of the core of the card. And in this case here, you will see that there's an antenna, going around on the edge of the card. That's why you do not put holes. Use your paper clip, etc. Put that through your card, and it can cut your wires. And you will see the chip here is connected with the wires to the antenna. So in this case here, this card here will support what is also said here as dual interface. You can have different layouts. You can do these constructions of these ID cards in various ways. You can have multiple chips. You can design that in many ways. But this is just one example of a card. The type here can, as I said also earlier, based on NXP Jacob, it can support FIDO, it can support DESFire. This one here, qualified signature creation device, is very important when the talks come to high levels and highly trusted qualified certificates, and also based on the eIDAS level high identity cards. And these standards here are very important in that area for the FIPS and the common criteria, because this is security standard that guarantees you that the chip complies to strict rules and can be used in any cases from, as I said, passport, IT authentication, and as well as many other use cases. Lastly, here is the question to clone or not to clone. Many people throughout the years have said to me that the card, it can be copied. That's a half-truth. What can get copied are the classic DOS access card, the travel card, the cards that we use for Cantina and Follow Me print. They are more simple. They're not as advanced as the real PKI-based card, because the simple MyFair cards here, they have typically a UID or card serial number, CSN, and that number can be read very easily and copied to another device. It can be a phone that can act as a card, or it can be a different another card it can be cloned into. So those technologies are not necessarily kind of guaranteed secure. They are very useful in many practical ways. You can compare this to some of the physical metal keys that we normally use for doors. Some of those keys are not that advanced. They can also be copied or cloned at your local shop that serves you for that. But going to a PKI-based card with a PKI chip, those cannot get cloned. And this is exactly because of the secure module that is inside the card, and the way that the keys are there, and the way this is physically and technically is designed is simply not possible. It cannot be done. So these cards are secure, and these cards here are not secure in terms of IT security. And with that, I would just say thank you for listening. I hope I will see you back on the next Legal Tech video. And yeah, thank you.